Welcome to the Green Room, where we explore the environmental issues that impact our world. Today we'll be talking with Kris Olsson, a watershed ecologist with the Huron River Watershed Council. Today she's here wearing her other hat as a volunteer with the local chapters of the Climate Reality Project and the Citizens Climate Lobby. Kris is here to talk with us about the impacts of climate change. Kris, welcome to the show.
Thank you, Barbara.
So in your work with the Huron River Watershed Council as a watershed ecologist, can you give us any examples of how climate change might affect ecosystems in the watershed?
Yes, in fact, the Watershed Council has a special edition of our newsletter all about climate impacts on the Huron River watershed, but they include, of course, warmer water. One of the major impacts for the Great Lakes are more intense storms, and we've seen that, of course, this year and in past years, and that creates more stormwater runoff, which goes into the waters and can create things like more algae blooms and other kinds of pollution.
And with your volunteer work, tell us what the Climate Reality Project is.
The Climate Reality Project was founded by Vice President Al Gore, and he's been going all over the world doing climate leadership trainings. And so people like me go to the trainings. They're about 2 or 3 days, and we learn all about the climate and ways that we can teach other people about the climate and create climate action around preventing more climate change.
And how about the Citizens Climate Lobby? What's that?
After I went to the Climate Reality Project training, I came back to Ann Arbor and wanted to do something with my training, and immediately found the Citizens Climate Lobby. A lot of people from that group had also attended the training, and so I found the local Ann Arbor chapter, and their mission is to pass in Congress a carbon price legislation that would put a price on carbon and then return that money to residents in the form of a dividend.
Okay. And you give presentations for both, so
Yes.
you're really good at this mechanics of carbon dioxide emissions, how they create changes in weather. So that's what we'll be talking about today. So do you want to start out with how does it change weather?
Right, so as we all know, the sun heats up the earth, and light and energy hit the earth, and a lot of it bounces off the earth and back into space. And the reason there's life on earth is because we have our atmosphere that traps a lot of that energy and heat. Since the Industrial Revolution, when we started burning carbon and methane and other greenhouse gases, that has gone into the atmosphere and trapped more of that heat and energy than has been trapped in the past. And so, you know, since the Industrial Revolution, we've been pumping millions of tons of this carbon dioxide and methane and pollutants into that atmosphere, and that has heated up the earth.
Creates kind of a blanket.
Right, an extra blanket, if you will, on the earth.
And how's it affecting like summer temperatures?
Yeah, so as we all know, the temperature can be hot or cool at any one time. There's climate and there's weather, and so weather is what's happening in any given day. And so we can have hot days, we can have cold days during the summer or the winter. And what the extra greenhouse gases in that atmosphere do is they heat up the atmosphere, and they kind of weigh the dice on the probability of having a hot day or a cold day at any one time. So if you look at the weather patterns, you get kind of a bell curve of the average temperature, and then you have colder and hotter days. What's happening with climate change is we're seeing more of those hot days and less of the cold days. And as time goes on from the 1850s onward, more and more the bell curve is moving to be more, to have more hot days. And then there's even a new category of very hot days. And so, for instance, in the last 18 years, the 17 of the last 18 years have been the hottest temperatures on ever since we've been keeping records.
Wow.
So we've really skewed our bell curve.
And you're speaking of all over the world?
Yes, that's a global temperature. It's a little, sometimes we talk about global warming and climate change during the winter, and when it's really cold in Michigan, we think, oh, how can we be having global warming? But what we're not paying attention to when we think about the weather is what's happening, say, up north. In the Arctic, they've often had much warmer temperatures than we've had in the wintertime here in Michigan.
So global averages, okay.
Right.
And I've heard climate change causes extreme precipitation. How does that work?
That's right. And so when you think about the warmer temperatures in the water, that causes more water vapor to come up into the atmosphere. And so you've got warmer temperatures and you've got more water in the atmosphere. That's more energy to create more storms. And so as a result, in places like the Great Lakes and the East and other parts of the world, we have not only greater precipitation, but the precipitation comes as more severe storms. There's just more energy in the atmosphere, and weather just works on atmospheric energy and vapor and moisture.
It certainly seems like we're getting dumped on more than we used to be.
And we are, and it actually comes out in the data.
When it rains, it pours.
Yes.
And then there's also lack of precipitation.
That's right.
How does that affect?
So as the air warms, it draws more water out of the oceans, creating more water vapor. It's also drawing more water out of the soils. And so, and you look at places, especially in the Southwest here in our country and in many parts all over the world, we see great droughts. I mean, there's dozens of countries. I was looking over the slideshow that we learn how to give at the climate reality training, and there's dozens and dozens of slides showing shriveled up earth in places like India, Pakistan, the Middle East, and the Southwest part of the US. One of the projections is by 2100, basically most of the western part of the US and the southern part of the US is going to be in drought, severe drought.
Yeah, those aquifers could dry up.
That's right.
Yeah, not a good thing. And I guess the political instability that these droughts and floods.
Right, if you combine the flooding, and we haven't talked about sea level rise yet, but sea level rise is projected to, of course, continue, and that's some large percentage of the people of the world live on coasts, and so those people are going to have to move, and where are they going to go? And many of the migration issues that we're having today, I mean, they have political, of course we know about a lot of the political issues around that. A lot of those political issues have their source in drought, their source in floods, their source in some of the health impacts of climate change. I was reading the other day about people moving from Honduras and Guatemala and migrating through Mexico up into the US. They can't get a crop anymore, and they don't have a life left in those countries.
Wow. Yeah, I've heard it said that climate change is a risk magnifier.
That's right.
Makes all these problems worse.
Yes.
Let's see. Also, along with droughts, reduced snow cover, right? Snowpack, and then when it melts, the people downstream.
Right, and so in the wintertime, you either have, if you're in areas in the west, say Colorado, there's just not enough moisture because you have that drought effect. In places like Michigan, we still have a lot of precipitation, but it falls down as either freezing rain or maybe wet snow or
and I know
just
you're a
rain.
skier.
Yeah, and so we
skier,
all are looking forward to some skiing, and it's coming down as rain. Now that's a problem not only for us skiers, but it's also a problem for agriculture, for summertime use, because that snowpack, and it's a problem for drinking water because many people rely on the snowpack, especially in the mountains, to be your drinking water and last you through the summer. In Michigan, we rely on that snowpack to be there, and then when it slowly melts, it goes into the groundwater. And when we do have our dry summers, that groundwater is available to irrigate our fields and to keep our drinking water wells moving.
And how about increase in fires? Could that be associated with climate change?
Yes, and so as you have more droughts, as you have drier weather, that of course is going to increase the danger of fire. And we have seen those incredible pictures and the stories of the fires in California and in Colorado, up in Canada. My family's from Sweden. There were fires in Sweden, which I had never heard of before, forest fires. So that is a definite problem.
Yeah, I've traveled a little out west, Portland and California, and the haze. And
and that's an air pollution problem as well.
Intensity of hurricanes, are we seeing trends?
Yes, very much so. So like I was talking about, the extra water vapor coming up into the air is just more energy, more vapor in the air is causing storms to be more intense. That's true for hurricanes as well. And then in addition, because the ocean temperatures are so much warmer, those hurricanes form out in the Gulf, out in the ocean, as they come in towards land. The typical pattern is for a hurricane at whatever intensity, when it hits land, it tends to dissipate because it's churning up the water that's lower, that's on the bottom, and that's cooler water, and that kind of short circuits it. But that water these days is also warm, and so you tend to see these hurricanes that just sit there, and they rain and they rain and they rain and they rain. If we remember Harvey, like 2 years ago now, I guess, that just sat over Houston and rain and rain. In fact, Nederland, Texas, which I think is near Houston, got 5 feet of rain during that storm. I don't know, I can't even really imagine what that would be. And so that's a definite impact of climate change.
And what about the polar vortex we had last winter? Is
Right.
that related
It
somehow?
seems very strange that we would be seeing colder weather as a result of global warming. But in this case, because we're talking about global warming, climate change, so not particular weather where you are, there's something called the jet stream, which runs around the Arctic Circle. And so that's usually what keeps the warmer air down here and the cooler air up in the Arctic. And so a lot of times the weatherman will talk about, oh, the jet stream is coming down and we'll be getting these cold temperatures. And what happened last year and what will tend to happen now is that this jet stream is going to break up and you're going to have 2 jet streams, and so that colder air is going to come down and it's kind of like shoot down from the Arctic and into the lower parts of the states, or into Michigan and into the northeast parts of the states. And so that's what the polar vortex is.
Yeah, I always wondered. It's kind of confusing.
So it's kind of weather, I've heard people call it weather weirding.
Oh.
It's not necessarily climate. So climate change is a little bit vague sounding. Global warming sounds almost, for some people, kind of nice maybe. Weather weirding does sound a little more strange. And it is more like that because I think meteorologists it's making it more difficult to predict what's going to happen. Because this extra energy and vapor and all of this, it doesn't fit into our regular way of looking at how to predict weather.
And then there's positive feedback loops, and I guess that exacerbates the urgency of the situation.
That's right. And so if you remember, I was telling you about the solar rays coming in, hitting the Earth, and the greenhouse effect stopping that. Well, as that happens and it hits the polar ice caps, that ice starts to melt. And as that ice melts, it's revealing Earth when the ice goes away. That is darker. And so instead of a lot of the sunlight bouncing off of the ice, it's absorbed by the Earth, thus increasing the temperatures even more. In addition, as the ice melts over the ocean water is also a darker color than the ice, and that also absorbs more heat. And so it gets even hotter, which then causes more to heat, and so that's your positive feedback loop.
I see.
The other positive feedback loop is up in the polar areas. We have tundra. That tundra is holding in the permafrost. That means it never melts. Well, now some of that permafrost area is starting to melt. And it's releasing methane gas because it's been tied up in that tundra for millions of years. And so as that methane gas is released, that is a much more potent greenhouse gas than even carbon. So that's causing more heating and more heating. And so there's 2 positive feedback loops going on there.
A vicious cycle that escalates like
That's
runaway train,
That's
some
right.
people say. We're coming to the end. How about some resources where people can find out more information?
So most of the information that I was telling you today, you can find in the International Panel on Climate Change report, and you may have heard of this. They've been coming out with reports for several years now, and then there's also the National Climate Assessment, which focuses on the United States, and so those are both available online.
People can Google, right?
Right, exactly. You can Google IPCC. You'll find plenty, and NCA, or National Climate Assessment.
Okay.
Absolutely.
Great. Well, thank you very much for being here
Oh,
today.
you're welcome.
It's been
Thank
really
you.
informative. For an online archive of this show and previous segments, please go to washena.org/greenroom. Thanks for joining us in the Green Room.